When setting about designing a valve-based project, we ask, is there any point in considering the use of a battery output valve to drive a speaker? These days we're conditioned to believe that you need a couple of watts minimum to drive even the smallest speaker, so the idea of using something with a quarter or a fifth of a watt is surely a no-no. In reality, of course, this is nonsense. Whilst most battery valves are economical in power for obvious reasons, there are a number of mains valves that have a relatively low output too, yet still expected to drive a loudspeaker. To dispel this theory, our experiment here will at least show what an ordinary low-power battery valve is capable of. Hardly a project like most of our other videos in this series, but technically it could be, as it's being built into our well-used universal chassis. Here you can see the components needed in addition to those already mounted on the chassis. This is the simple circuit we'll be using for our experiment. Note that the HT will drop to around 85 volts when we draw the 10 mA or so from the circuit under power. There was a temptation to build a second driver stage with a second battery valve on the same chassis, but it seemed to defeat the object of seeing just how well the valve would perform on its own. A point to make about the valve heater is that most early battery valves were designed to run off a lead-acid accumulator with a 2-volt output. It was only with the increased usage of dry batteries did the 1.4-volt filament start being produced. Here we have the setup we'll be using to test an old battery valve, a DL35 to be exact in here, with an octal base. This is another DL35, interesting to have the Ever-Ready make on it. I don't think Ever-Ready ever made any valves, but that's the make put on the side. The valve is in a standard octal base, as you can see here. This is just an ordinary octal. This would have been used in a larger piece of equipment rather than a piece of portable equipment because they're quite a sizable beast when you think about it. Anyway, right, what we'll be doing is we're going to feed that initially with the output of this simple oscillator here. We have it on as a sine wave on 1 kHz, and we're going to see what that does when it goes through the amplifier. It reads about just over 10 milliamps, which seems a little bit on the high side. I think maybe an adjustment of the screen resistor might bring that down a fraction, but I think it's supposed to run in total about 8 milliamps plus a few milliamps, about 4 milliamps for the screen, so it may be spot on. It takes a little more current than the smaller valves you found in the 1950s, like the DL96. DL96 was one of the last output pentos that we had for making, output stages for driving speakers, etc. So we have a scope over here. We're simply going to look at it. The scope is on 5 volts per division. I expect that turning this up will gives us just around 20 volts or just over. So we turn it up, it's just over 10 milliamps. That's reading on the scale. This is a times 10 scale. Nothing on the scope. Let's wind up the volume. It's quite a decent waveform. There's not a lot wrong with that. And that's giving us 5, 10, 15, 20. That's about 23 volts on the scope. Let's have a quick look at that. Switching the signal generator to 10 kHz. Same amplitude again. We adjust up the time base. Still pretty much the same. So those are the results using an audio frequency oscillator. The question is, what does program material sound like? And the way to find out is to play something through it. So what we've done is we've disconnected the oscillator and we've connected up to a radio tuner. We're on radio 4 at the moment. We'll turn up the volume in a minute. Speaker is quite a decent little speaker, these Ariston things, and not hi-fi by any stretch of imagination, but the sound is quite good. If you consider that this thing is pushing out maximum a quarter of a watt, it's 250 milliwatts. Is what the book says you can have from one of those. So let's see what it sounds like.
where does this 1 in 10 ratio come from? Well, one way to investigate this mystery is to look back through our evolutionary past, which is exactly what primatologist Professor Linda Marchant from Miami University
Interesting,
has done.
checking out
Now,
the
Linda
waveform
is a
at the same
lefty,
time.
and she began studying wild apes in Africa to try and find out whether left-handers are in the minority there too.
Well, in my books, there's not a lot wrong with that, which I think just goes to prove that if you're looking for an output stage, a small output stage, say, for a receiver, possibly battery operated one. I mean, that's obviously where these particular low voltage filament ones score in as portable devices. But certainly we're led to believe that you need megawatts to listen to a simple CD player or something, you know, with a headset. You don't. You can actually produce a reasonable sound with a quarter of a watt or even less. So hope that's food for thought. Thanks for watching the video.